Have you ever stared at a tub of spread and just thought, how do they do that? How do they take liquid oil and turn it into something perfectly creamy for your toast? Well, it's not magic, but it is some seriously cool food science. Today, we're going to pull back the curtain and see exactly how these everyday staples get made and what the real deal is with all those different labels. All right, let's get into it.
So here's our game plan. We're going to jump right into the action with how it's made. Then we'll break down what's actually inside your spread. After that, we'll get into the nitty-gritty of margarine versus fat spread. Check out the official rulebook manufacturers have to follow, see what happens when things go wrong, and finally, follow these products all the way from the factory to our tables. Okay, first things first, let's talk about that journey from a bunch of oils and ingredients into the smooth, finished product in the tub. This is where the real transformation happens, and trust me, it's an incredibly precise process. You can think of it like a 5-step dance. First, you get your 2 teams of ingredients ready, the fats and the waters. Then you basically force them together with some intense blending. That's called emulsification. The whole mixture gets heated up to make it safe. That's pasteurization. But step 4, crystallization, that's where the real magic happens. Super fast cooling turns the liquid into a solid. And finally, it gets packaged up and sent on its way. So what's the big secret to that perfectly smooth, creamy texture? How come it's not just a greasy, separated mess? Well, it all comes down to these microscopic things called beta prime crystals. The entire point of that rapid cooling step is to create a massive network of these tiny needle-like crystals. They all lock together to build a structure that's solid but still spreads like a dream. And this quote just hits the nail on the head. Getting that crystal structure right is literally everything. If you cool it too slowly, you get bigger, chunkier crystals, and what you end up with is a spread that feels gritty or sandy in your mouth. Nobody wants that, right? The entire feel of the product gets decided in this one super critical step. Okay, so that's how it's made. But what are they actually mixing together way back in step 1? To really get what these products are, we got to look at those 2 teams of ingredients that are the foundation for every single spread out there. So, let's ask the big question. When you open that tub, what are you actually looking at? You know the old saying that oil and water don't mix? Well, they don't, unless you have a really clever process and just the right ingredients to make them play nice. Every spread is what's called an emulsion. It's a fancy word, but it just means a stable mix of fat and water. You've got the fat phase, which is kind of the boss. It provides the structure, that creamy feeling, and it carries all the good stuff like color and flavor. And then you've got the water phase, which is where things like salt and preservatives are. It exists as teeny tiny droplets suspended inside the fat. All right, so we know how it's made, and we know what it's made of. Now, this is where those names you see on the package, margarine, fat spread, finally start to make perfect sense. These aren't just clever marketing words. They are actual legal definitions based on what's in the mix. Let's start with the classic, margarine. It's defined as an emulsion that's a lot like butter, but the really key rule is about what it can't have in it. By law, real margarine cannot contain any animal body fats or mineral oils. It has to be based on plant and vegetable oils. A fat spread, on the other hand, is a much, much broader category. It's still that same water in oil setup, but the source of the fat is way more flexible. It can come from milk fat, from vegetable oil, or even a mix of both. That flexibility is really the biggest difference. And this table just lays it all out so clearly. Just look at that top row. Fat content. This is the big one, folks. To earn the name margarine, a product must have at least 80% fat. Fat spreads, though, can be anywhere from 40% all the way up to 80%. That one single number is probably the most important difference you'll find in the entire aisle. Now, that 80% rule, that's not just a friendly suggestion, it is the law. And that brings us to the official rulebook, the standards that every single manufacturer has to follow, right down to the letter. Think of it as their quality control playbook. Pretty much every food you buy is governed by a set of standards. This is to make sure it's safe, consistent, and that it actually is what the label says it is. For spreads, regulatory bodies like the FSSIA have super specific requirements for everything, from fat content to vitamins. And what's really interesting here is just how detailed these rules can get. For margarine, you can see the fat has to be 80% or more, moisture is tightly controlled, it has to be fortified with vitamin A, and they even regulate its melting point. That's to make sure it melts in your mouth, not into a puddle on the counter. So let's just hammer this point home.
If you remember one thing about the rules, make it this number: 80%. The second a product's fat content drops to 79.9%, boom, it cannot legally be called margarine. It has to be labeled a fat spread. It's a hard and fast line in the sand.
Okay, so that's the plan when everything goes perfectly, all guided by those strict rules. But what happens when that complex little dance of crystals and emulsions kind of trips over its own feet? Let's take a look at what can go wrong.
And you can see how all these problems link right back to the science. For margarine, if that beta-prime crystal network we talked about is weak, the oil separates out. If you get the wrong kind of crystals, you get that gritty sandiness. For fat spreads, which have more water, you can get leakage, or it might be impossible to spread when it's cold. All right, we've been through the factory, the science lab, and the official rulebook. Now let's bring it all back to where it really matters: our own kitchens and the wider food industry. How do we actually use these things? Well, their use is incredibly broad. I mean, of course, there's just spreading it on toast. But these products are also absolute workhorses in the food industry. They're used as shortening in bakeries to make pastries flaky, they're used for cooking and frying, and they're a key ingredient in all kinds of candy and sweets. So there you have it, from the physics of tiny crystals to the legal definition of fat content. The next time you're grocery shopping, you'll know that the difference between those tubs isn't just a name. It's a whole story of chemistry and engineering. So the question is, now that you've seen how it's all made, are you going to see that aisle a little differently? Thanks for joining me for this explainer.